In some line, take a point A, take another point B, call this as initial point and call this as terminal point. Then this is called a vector and denoted in this manner. This, by the way, is also called directed line segment. So a vector is a directed line segment. Length of the segment represents the magnitude or the value of the vector, and this arrow, which is from initial towards the terminal, that is direction of the vector. Vector also follows certain law of addition called triangle law. We say that the two vectors are equal if magnitudes are same, that is the length. Now this line, that line is called support. So equality of two vectors, length same, support can be same also. So if I extend this support, it could be the same support or it could be some parallel support. And direction should be same. Three things: same length, either the same support or parallel support, direction same. These three conditions for equality of vectors. Vector is represented like this. This is initial, this is terminal. It can also be represented by a single alphabet. Maybe I can call it as this. If I want to talk about the magnitude, I would put two bars like that. Zero vector. Initial and terminal points coincide. We also call it null vector. Magnitude is 0. So talking about direction makes little sense. Technically, This is the way to write it. Unit vector. Vector whose length is 1 unit. So take vector of any length, divide it by its own magnitude, and you get the unit vector of that vector. Direction of unit vector is same as the direction of this vector. Along the 3 axes, we permanently define I, J, and K unit vectors. X, Y, and Z make 90 degrees with each other, but I have kept one more thing in mind while drawing them. For example, I could have drawn Z below. Even then, there would be 90-degree angle. So why Z was drawn up? You know the rule of cross product. I want I cross J to give me K. So that way, it must be up. We'll be talking about cross product later, but you know it's from physics. Parallel vectors. We talked about equal vectors. In case of parallel vectors, their magnitudes don't have to be equal. It is basically either the same support or parallel support, as simple as that. Support is a line. Line has infinite length. Either the same support or parallel support. But then one can say that, how about the direction? Shouldn't direction be the same? For parallel vectors, no, not necessary. The definition only says either the same support or parallel support. So from that definition, even this vector and this vector, they are parallel. If two parallel vectors have got same direction, then they are called like vectors. Parallel vectors having same direction, like vectors. And parallel vectors having opposite directions, unlike vectors. Okay? Next is collinear vectors. We talked about parallel vectors. One more condition you need to attach. either the initial point or the terminal point. One of them has to be same. If we are going to say that two vectors are collinear, then either the initial or the terminal, one of them must be common. So here, OA and OB, they have to be parallel. Collinear vectors have to be parallel. In addition to that, either the initial point or terminal point in common. Here, initial point is common. So we have OA and OB as terminal vectors, as collinear vectors. OA and OB as collinear vectors. I can have third vector, fourth vector, I can have several vectors. OC I can have. So here OA, OB, OC, they're all collinear. So for two vectors to be collinear, they have to be parallel. But if we just say co-initial vectors, then only the initial point has to be the same. There is no condition for them to be parallel. So I can draw so many vectors. They are all co-initial if they are like this. So if you think of some coordinate system origin and these as points, then all of these become co-initial vectors. Then free vectors. Initial point is not specified. Initial point is not specified. Some force is acting in north direction. That's it. North direction. Initial point is not specified. These are free vectors, and we generally talk about free vectors. You have seen how vectors were moved in physics freely. So if there is no condition about fixing the initial point, you just move them freely. You just maintain, when you move a vector from one place to the other place, you just maintain the rules that direction should be the same, length should be the same, those things. So whether I draw this vector here or here, it's just the same story. We can now discuss vector algebra. First, we define multiplication of vector by scalar. We will have to define things because it's like learning a new language. So we define things, then we make deductions based on the definitions. So we define multiplication of vector by scalar. We define this as a new vector whose length becomes k times the original length. or whose magnitude becomes k times the original magnitude. Direction may be same or may be opposite depending on the sign of k. If k is positive, direction is same. If k is negative, direction is opposite. Next, we define the triangle law for vector addition. It's a definition. So if two vectors represent two sides of a triangle in this manner that terminal of this meets with initial of this, then this vector represents their sum. So that's the definition of triangle law. Next comes a deduction, and that deduction is parallelogram law of addition of vectors. This is a parallelogram. Then parallelogram law says that OB is OA plus OC. How are we going to prove it? Well, it's quite simple actually. We know from triangle law that OB is OA plus AB, and since this is a parallelogram, length of AB is same as length of OC. They are parallel also. Their parallel lengths are equal, even directions are equal, they are equal vectors. So in place of AB vector, I can write OC vectors. That's it. Next is, it's a theorem you can say. Vector addition is commutative. To prove this, consider a parallelogram. These are going to be equal vectors. These are going to be equal vectors. If I use this triangle, then I can say that A plus B is C. And if I use that triangle, using triangle law, I can say B plus A is C. There's no difference in these two. And therefore, A plus B is B plus A. Any questions up to this point? Let me know. Now, next theorem is vector addition is commutative. So, how do we prove it? Let this be A, let this be B. Let this be C. Join these, join these, and join these. Then, from triangle law, this will be A plus B, from triangle law, this will be A plus B plus C. A plus B first, we have added already, and then C. This fellow. Now, consider this triangle. This is B, this is C. So this is B plus C. And now consider this triangle. A added to bracket B plus C will be this. A added to B plus C. Clearly these are going to be equal, these two. Let me know if there is any question. Vector addition is associative. We have proved that. We talked about scalar multiplication. We can also talk about multiplying by -1. Multiplying by -1 will be just this. You can call that negative of a vector. Once we have talked about negative of a vector, we can define subtraction, vector subtraction. Consider some vector b, take its negative first, and then add that to A. That's how we define vector subtraction. A minus b is defined like this. So geometrically, suppose this is A, and this is B, and I'm looking for, say, B minus A. Then how would I do it? I would take minus of A first, which would be this. That's it. We have found B minus A. So that's how we can handle vector subtraction. Now, we can generalize the triangle law also. Parallelogram law we have discussed. So let's make it the Polygon law of addition. Draw as many vectors as you wish. Making sure that initial and terminal points are in this order. So like that, if you reach here, considering n vectors, then the vector sum is given by this. some more deductions that can be obtained easily. If you add a vector to a zero vector, you will get that vector. Then this, if k1 and k2 are scalars, numbers that is, then this, now from triangle law, this is what we have. So length of this side will be mod A. I'm just writing A for that, mod A. Length of this, length of this, or let me use this symbol only. Now you are dealing with triangle geometry wise. So sum of two sides is more than the third side. So we have this rule. However, there can be one case in which they are collinear. And in which case there will be equal sign also. So generally speaking, this is the law. Any questions? Let me know. And likewise, how about the difference? In a triangle, difference of two sides is less than a third. Now, I would like minus b here. So I may have to change the figure a bit. So this is A, this is B. So this will be minus B. And this will be sum of these two. A plus minus B. Now let's apply this property in this triangle. Difference of two sides is less than the third. Now, we can subtract bigger length from the, we can subtract smaller length from the bigger length. So bigger minus smaller makes more sense. So let me put a mod, or you understand it this way, that you will subtract smaller from the larger, whatever way you understand. And also, vector or its negative, they are not different magnitude-wise. They are only different direction-wise, vector and its negative. That's it. Now, if they are collinear, then equality condition is also possible. Right? So that's the general rule. Any questions? Let me know. The concept of position vector. You can represent a point by vector also. You just need a fixed origin. So a point can be represented by a vector. And if that is done, then vector OP is called the position vector of point P. It behaves just like other vectors as far as the properties that we have discussed are concerned. So it is with respect to somebody. So that's about position vector.